Welcome to Machine Learning with Teachable Machines. I promise you today is going to be a fun day of learning and doing. We want to go ahead and appreciate you all for being brave and taking a stab at this. We're looking forward to hearing your ideas and thoughts. We're excited to hear what you're going to bring for this place. So this is not a space where you hold anything back. There's no wrong answer. This is a safe space. So come up with your ideas. We're looking forward to leaning on your creativity. So today we're going to explain to you what machine learning is. We're going to train a model using a teachable machine, and we're going to use classifiers to build a gesture machine. I hope everyone's as excited as I am. Also, we're going to top this all up with how to keep learning about machine learning because today is just a tiny little bit of it, just a start to give you a small taste of what machine learning is going to be. What is our goal? So our goal today is to train a model to classify hand gestures. So basically, our hand gesture is going to be limited to the thumbs up or thumbs down. So think of a model like a blueprint or a template or a recipe, a way for you to teach a computer something. Just like you would be teaching your dog, if you have a dog, or to play fetch. You first would say, oh, to hold the stick and go, and I try to pick it up, go over there. So we have to model it for them. Or you're trying to teach, someone how to do the latest TikTok dance. You have to, let me show you how it's done first. So you have to model it for them. So a model is a set of instructions for your computer that will help the computer understand and learn from the information you gave it. We'll also learn about conditional statements that would turn these classes into image. I will explain a bit more about conditional statements and classes as we go. So very important housekeeping items. We have two TAs here that will help out with any questions that you may have. I'll have them introduce themselves later. And you can use the raise hand option. It's on the bottom. Or you can use Control Alt plus H, and you can use that to ask questions. Freely use the chat rooms for discussions. And here we have community mindsets, and this is what we have on there. In this environment, we are all learners. At the same time, we are all teachers. So I'm learning from you all with your ideas, with how you do stuff, because you guys have perceptions that I don't have. And at the same time, I'm here to teach you what I know. Everyone here is valued and respected. What you have to say matters. And we respect what you're bringing to the table, so there's no wrong answer. Don't hold back. Don't feel like, oh, I'm not really into machine learning. I don't know what that is. We want you to be as creative as possible. We expect you to get stuck. We expect you to be confused about things. We want you to break things and we want you to try it again. That's how you learn. That's how you learn in engineering. That's how you learn in science. That's how you learn in arts. That's how you learn in anything, even as a baby when you were learning to walk. Like I said earlier, this is just an intro. We hope we can create a thirst for machine learning that you will want to learn more from. So I'll go ahead and introduce myself, and then I'll have the TAs introduce themselves. So hi, I'm Chioma Asor. I started a group called STEAMDivas. We're a nonprofit organization in Florida. Our main aim is to help young girls get excited about STEM, which stands for science, technology, engineering, and mathematics. And we do this by giving them a hands-on experience and showing them that they can be leaders in this field. We also add arts to STEM, making it STEAM, because we believe that creativity is really important in science, technology. So we want more girls and women to be involved in these areas where they've been less represented in the past. And we don't want them to feel like they have to be anything other than themselves. So our organization is really focused on just encouraging more girls and women to get into STEM, but also making sure that they have a supportive and positive environment where they can succeed and do so. So I'm gonna go ahead and pass this on to Philippa so she can introduce herself.
Sure. Hello, I'm Philippa, and I'm a graduate student, and I'm studying geographic information sciences, which is very much at the intersection of arts and science. So that is why I'm very attracted to STEAM. And I'm just really happy to be here and very much also incorporating machine learning into my studies, especially related to image analysis, where you can use it to categorize things, count things, see change between images, change over time, and even do predictive analysis to predict what will happen in the future.
Nice. Okay, the next person is going to introduce herself. The second TA here is Elizabeth.
Hello, everyone. I'm Elizabeth. I'm a software engineer, and I am so fascinated about learning. And when I see an opportunity to learn, I grab it. So, as you take on this ride, I hope you learn as much as I love learning. Thank you.
All right, that's awesome. Thank you, TAs. And I'm going to go ahead and move forward here. So, today we're talking about machine learning. Machine learning is a field of study that gives computers the ability to learn without programmers writing the rules on how they can solve a problem. You know, so typically a software engineer like Elizabeth, what they do is they take, they study the problem and then they write rules, and people like us too, we all write rules on like this is how we want the problems to be solved. And then we say, okay, this is what we expect the results to be. That's typically what we do with a typical program, and we know what the solution is going to look like. However, with machine learning, it's a bit different. We study the problem, then we provide the machine with data that we use to train it. We tell the machine this is the rule, this is what's going on, and then the machine goes ahead and they write the rules and provide us with a solution. We do not know the rules that the machine writes, so we call it a black box most times. However, we can determine if the rules are right by testing it. An example of a machine learning program that we typically use in our everyday lives is a spam filter. If you check your emails, you're gonna see that there are some things there that goes into your inbox, and there's some things that goes into your spam folder, and that is done through machine learning. Machine learning is also used on social media. And you guys, being on Instagram or TikTok, you see that sometimes there's an automatic flag on what people find, on what people call offensive comments or offensive comments. And this is done with machine learning. There's some form of classification. Classification is, coming up again, and the machine creates the rules. We don't know the rules, but we know the results is supposed to look like. So I will go ahead here and share with you a short video about machine learning.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing.
Awesome. Were you able to hear, or that just was just on my side?
I just saw it, but it's very visual, so I definitely got the message. I think communicated well.
Okay.
Yeah, me too.
Awesome. So this is the part we take a little break to answer questions if anyone has on machine learning. And since we have no questions, I'm gonna move on to discussing about classification. Now, classification is a very, very interesting word. So I don't know if anyone here has understands anything about classification, has any questions. Well, I'm just gonna go deep dive into it. So classification is a way to categorize things, right? Just imagine in school how you all classify yourselves. Like when you're eating lunch, you sit in the band kids this place, the cheerleaders that place, and create these groups together, or you are classifying your color setup, and you're like, this is my day makeup, and this is my nighttime makeup, and you have things that you use to determine what falls under daytime makeup and what falls under nighttime makeup. Or you have different toys you like to play with, and you're like, okay, this is a toy I like to play with for winter period, or I like to play with for summer period. No, we all have a way of doing classification. Like example, what we talked about with the spam filters. Classification is the way that the spam filter sorts the email. So if you use Google, it will sort things into inbox, the spam filter, and then within the your inbox mail, it sorts it in within important and all the other mails. So there is several levels of classification going in just that Gmail that you have. So how does machine learning know how to classify and make up the rules by following examples? So we're going to look at this example we have here. Half the monkeys at the Lincoln Park Zoo are known to bite human beings, and now your task as a group here is to you know identify the monkeys into two classes. Class one we're going to call the biting monkeys, and then class two is going to be the non-biting monkeys. So all we have here is, for example, this picture. If you look at these pictures where we say, okay, all the class one biting monkeys is this monkey on the side, and all the class two biting monkeys is this monkeys on the side. Can you tell me, like, what do you think is the rule, to determine the class that the monkey belongs to? Well, as you can tell, all the class one biting monkeys is showing us their teeth, and all the class two non-biting monkeys doesn't show their teeth. So we can say, oh, the rule is if a monkey shows the teeth in the picture, it's a biting monkey. And that's an example of how we kind of come up with what our model rules are going to be like. So now, if you pull up the green monkey card that I sent to you, you're going to see a list of 20 monkeys. And we have a new rule that we created to classify these monkeys. So the class 1 biting monkeys will be the 6, 7, 8, and 15 monkeys. And the class 2 non-biting monkeys will be the 1, 2, 4, 9, 12, 14, and 17, and 18 monkeys. 14, 17, and 18 monkeys. Now, the challenge I'm going to give to you all is taking these rules that you know, go ahead and create your own rule on how you think you will classify the monkey. There's no right or wrong answer here. I want you to be as creative as possible. What things do you think will unify the monkeys that will make them biting or non-biting? Feel free to dig into this with your group. So what set of rules and steps did you use to make your prediction of what the rules are? You know, did you identify which monkeys are biting monkeys and which monkeys are non-biting monkeys? So I'm gonna go ahead and share what our results are. So this is what our results came out based on the model that we created. The class 1 biting monkeys includes 3, 5, 11, and 19. And the class 2 non-biting monkeys includes 10, 13, 16, and 20. Are you close to what our models is? All right. Let me go ahead and show you a breakdown of how we came up with our model. So if you look at this blue monkey that we gave to you, you will notice that all the biting monkeys are the ones highlighted in yellow, in the yellow circle. You see all the biting monkeys fall within this range and this range. Can you tell me what are the similarities? So if you see, all biting monkeys have the X, the cross-eyed there, and they all have the same smile here. So this is how we created our model. So you're wondering, okay, what are models? Well, models are a set of rules and steps that we use to make a prediction, right? As you can tell, we said, okay, these are the rules. Any monkey that has a smile and a monkey with a cross eye, we're gonna call it a biting monkey. And in real life, it's usually based on, okay, this is what we're doing. We don't know what's going on, and then the machine comes up and says, oh, I figured out the model, and that's the part we don't know. Now let's dive a little bit into what we call conditional statements. So I'm going to ask you a question and I want you to respond with the emoji. So if you are in 9th grade, click the heart emoji. Otherwise, click the clap emoji. As you can tell, there is something called condition. So this is how we come up with our conditional statements. A condition is kind of like a sentence that you make that somebody needs to meet. And if they don't meet that, then they have to go into the other box. So this is how conditional statements are made. This is a very, very good tool that we use in programming. When you're trying to get people to follow rules, you say, oh, if this is a condition. If they don't meet it, then you throw them into another box so that they can do something else. So here we can ask another question like, if you're the oldest sibling in your family, or you're an only child, automatically makes you the oldest sibling in your family, raise your hands. Otherwise, raise a fist. As you can tell, the conditions allow us to differentiate everybody into separate groups, right? So if I ask you, what condition is the statement checking for? Can you answer that? Of course you can, because The condition is checking for who is the oldest sibling and who isn't an older sibling. So who is an older sibling is the condition that you're checking for. Everybody else falls within the group. If they're middle child, they're the last child, they all fall within the group. Now with JavaScript, we have what we call a syntax. These are like special symbols and formatting that the computer uses to understand what we're trying to do. Do you notice any syntax on this image here? Yeah, so if you notice there's this squiggly braces over here and a squiggly braces over here, and there is if, and the condition goes in here, and then we tell it, if a condition goes in here, we're telling it everything that's happening within the squiggly braces, do it. Else, if it doesn't fit the condition, everything that's happening between the squiggly braces, then do that. So this is one way that JavaScript has created syntax to let the computer know what we want to do. So it's very easy way to tell the computer, if this condition is doing this, do this, and then you have those braces, and that's the only thing inside those braces it will do. And anything that's not within those braces, within the condition, goes around and follows the else braces. Now, there's no need for you to sit around and try to memorize the rules and syntax. I'll show you how to get the correct rules and syntax. That's how all programmers work. But then there's some things we call multiple conditions. Like what would happen if you want to create two conditions? Like say, okay, you want to find out who is the oldest child, you want to find out who is the last child. Then this is where we bring in what we call multiple conditions. So in this case, instance, I wanted to give homage to STEAM. So we wanted to find out who in here like arts, and then who in here like STEM, and then the people that like both of them. So if you see, we have two conditions. So first condition is, if you like art, give a heart emoji. Otherwise, if you like STEM, give a thumbs up emoji. Otherwise, and I'm going to say these are the people that fall within both groups, give a celebration emoji. So yeah, you can get multiple conditions as much as you want. You can definitely have more than one condition depending on what you're trying to do. And when you have multiple conditions, the syntax changes. So we have the if condition goes in here, and we still have the braces, and it tells you what happens when the if condition 1 is met. And then we have what we call else if. The else if gives you a second kind of condition which is completely different from the first condition. And everything that happens within the squiggly braces is what happens to that condition when it's met. And then we have the else, which is everybody else falls down there. So if you don't meet condition 1 and you don't meet condition 2, then you go into this final bucket, which is why we call it the default output. So now, like I said, there really is no need for you to remember syntax. What we do as programmers is we Google everything. So how do we Google things? We first of all write down the language and we say, what are we trying to do? So here we like Google JavaScript if then statement. If you're trying to do else is, you go JavaScript else if statement. And if you go through the list, you're going to see a syntax showing you exactly how to do it. So this is our personal empowerment thing that we're going to tell you. Whenever you're writing your code, read the error message. Try to see if you can understand it. You can take the error message, you can post it on the Google search, and it will tell you exactly what is going on, or somebody's had a solution that has solved it. If you are trying to get something achieved and you don't know how to do it, go online, check a working example. Write down what you're trying to do and see if there's a working example that you can change to match your variables or what you're trying to accomplish. It may not be exact, or you can figure out how you can make it closer to what you want to do. Like I said, you Google everything. That's what programmers do. We Google everything. And then you have your peers. You can ask each other, how do I get this done? How did you do yours? How did you make it work? Or you can ask your mentor. You can ask any of the TAs. You can ask somebody you know that is used to programming. Programming is something that anybody can do if they want to, because there's so many outlets out there that can give you access. Be as creative as possible with programming, and the more you fail things, the better you're going to understand how a program works. So now we're going to go into the demo part. So first of all, we're going to have 3 steps to this. We're going to train the model, we're going to export the model, and then we're going to use the model. So I sent you guys a document, and it's going to show you how to do the training of the model, and has access to those links. So we're going to go over to the document. Let me come out of there. So you see on the document, there is a link here that when you click on it, it's going to take you to the Teachable machines. And then I'm going to walk through this with y'all. So if you go back to the instructions, it says go rename your first class thumbs up. If you click on the class 1, you're going to have an option to type in there. Make sure you write thumbs up the way that it's written in here, so that your variable can match your instructions. So you see, I could copy here and just paste it in here, or I could type it. And once you type it in, you click on anywhere up here and you have thumbs up. The next instruction says click on the webcam. Allow this time, allow on every visit, depends on what you want to do. But don't click on never allow, because your camera, you need your camera to be able to train your model. So you can see me on the camera. Now we have the option to hold to record. Hold to record allows you to be capturing the emails you want. Now you want to make sure that the image you capture is a sample of what you want, and this is where we want everything here to just show a thumbs up. So I'm going to try to remove myself from the image and just have just my thumb. I could do this by cropping this so it will have a smaller interface, and I'll move right back out of the image. And then you just see just my thumbs up, and I'll do done cropping. So try your best to get as much of yourself in it, and then you hold to record. Hold to record. So what we're doing, we're creating an image of thumbs up. I'm going to be moving my thumbs everywhere, because this will give the computer an idea what thumbs up looks like. At least my thumb. And you can take as much pictures as you want. The more samples you have, the better for the computer to learn. If you're finished recording, you could also go around and look at those images if you want to, and say, oh, okay, this doesn't really say, oh, let's say you mistakenly got your face in there or got a teddy in there. You can just go ahead and delete that using this. Going back to the instruction, now we're going to go ahead and do something similar to the second class. So you can see here, the second class is thumbs down. I'm going to type it in this time around. And I'm going to start my camera. Once again, I want to get myself out of the picture so that every time I shows up, it doesn't see that that's a thumbs down. I want to get a really cute thumbs down too. All right. Okay, this is as best as I can get my thumbs down. So one way we're doing here, we're trying to train the machine to see the, okay, this is thumbs up, this is thumbs down. You know, this is two gestures that the machine can learn on. You can get as much image as you want. You also have the option to add another class. Let's say you want to add another gesture to the machine. That's up to you. But for what we're trying to do, we're just going to stick with thumbs up and thumbs down. Like here I have 113 samples. I have 119 samples. So now I'm going to take all these images and train the machine. And this is where the training happens. Leave your tab open. Don't go anywhere else. Just stay on here. Let the training happen. Now the machine has completed training. Apparently you can tell that the machine is a bit confused because I'm sitting like this and it's like saying thumbs down 100%. Let me scroll down a little bit. See? I don't know why. So in that instance, this is kind of like me testing it with some data. I can do this and you can see my thumbs up is slow. It's saying it's thumbs down. If I do this, it's looking closer to thumbs up. But I think because my frame is in there. But what happens if I move out of the picture? See? It's 100%. And if I do this, it's 100%. Now at this point in time, if you're working on your machine, you can add more pictures. You can go back and click on webcam and add more pictures. If you feel like you want to train a little bit more, you can delete some pictures that you feel like it's leading it in the wrong direction. You have all of that availability on what you want to do. You could, you could take all of this and start all over again. You can completely delete the whole image and start all over again. But I think I'm satisfied with my image. I'm just gonna go ahead. So what, according to our instructions, our next step is for us to go ahead and export the model. So this is where it is. You go ahead and export your model. When you get up to this window, you're going to upload your model to the cloud. What you're going to do is going to upload your model to the cloud, and it's going to give you a link that you can add to the code that has already been written down to a certain level. So you click on this option to copy this link, and if you follow our instruction again and you click on your replies, it's going to open up a replit window and you can fork an existing code that's already written. So go ahead and click on your replit code for JavaScript. Go to the script.js, and on line 4 this is where you're putting on the URL for your image model. So I'm gonna copy what I copied. I'm gonna switch this because this is the first one I created. I'm gonna put the model in here. I'm gonna paste it. Control V works, and make sure I copy the whole thing. Typically this is gonna be like an empty space with 2 quotes on it. I already had a model in there, so I'm gonna remove that, and I'm going to replace it with the one I just copied using Control V. And now I'm going to go ahead and run my code. As you can see, you're going to be seeing a bit of it here. When I do a run, and make sure I'm using the right option. So my code says, I'm going to show you what you're seeing now with a smile. Then I'll walk you through the code. So if you look at my code, when you come down to line 70, where I'm using the prediction of 77, 73, because I made it change the code. So I'm saying if the predicted class is thumbs up. So this takes you back to what? Conditions, right? So basically what I'm saying here is if what I'm predicting, which is what my machine learning is using, the model class, if it's falling within the image that is under the class of thumbs up, make sure the emoji says use your smile. Now I want you guys to be as creative as you want. If you want it to be a smiling emoji, you can use whatever emoji you like within what you want it to show. I picked the smiling emoji, and that's what you're gonna have. And then I should probably comment this out because I added this in here already. And this is me commenting this out. You comment out by using 2. So now what it's gonna do is like, what happens if the image doesn't look like the thumbs up? Well, then it's gonna show a question mark, like what? Like what do you mean? So I'm gonna go ahead and run this again since I just commented that out. So now, if you look on the bottom, it's telling you thumbs down. So it's like, oh, this image looks like a thumbs down. So it's like, I don't know what this is. So I'm going to go out here and give it a thumbs up. See? Now we get a smiley face. If I give it a thumbs down, it's like, I don't know what that is. So now let's try to be a little bit more adventurous with our code, right? We want to be like, okay, what if we wanted to do something? You remember when we talked about multiple methods, like multiple conditions? Well, we can do this. We can say, okay, what happens if we have a thumbs down condition? So thumbs up, we want you to show one emoji, and thumbs down, we want you to show another emoji, right? That's what we want. So now I got the thumbs up, and if my predicted class is thumbs up, yeah, remember we renamed it thumbs up? Good. Let's try another one. If we're trying to give multiple conditions, this is where we come in with the else if. And I can go on here and I can do a search and say JavaScript else if statement. And I'll say, oh, W3 schools, great. Let me see what they say. So I can go ahead and look at an example. So if the condition, I can write all the things I want to be done. That's good. Then let me see. What do they have for else if? Well, we have the else statement. If, condition, else. Okay, we know what to do. But how do I write the syntax for else if? Well, there it is. So if the condition, which in my case is predicated class, well, at least that's what I think I called it. Yep. And then I have the else if predicated class is equals to thumbs down. So you can either copy all of this and paste it there and then make the changes like I did. But I already did it already, so I'm just going to go ahead and uncomment it. And then what in your condition, you're like, okay, predicated class, similar to what you have up there. I want it to be thumbs down, similar to what I wrote on my image model, thumbs down, because you want the class to match. Because then your machine's like, I don't know what that is. What class are we seeing? But now, since I already know what I name my class, I can do thumbs down. So what do I want it to do when the image matches all the image in that thumbs down stuff? I said, well, I want my emoji to show something. And for me, I picked the side eye because that's my favorite emoji. I'm always giving side eye. So I did pick the side eye. But if you notice, even though it's saying thumbs down right now, it's not changing it to that side eye emoji because I haven't run it. Well, I still want to be able to create a basket that everybody that's not, every image that's not a thumbs up or a thumbs down can fall into. Let's say if I have an image of a pink teddy bear, what does it look like? Does it think it's a thumbs up or thumbs down? So no. So you wanted to be able to fall into another place, and I wanted to show like a question mark, like, what are you doing? What's that? So that's what emoji I picked. But however, this is your creative space. You can do whatever you want. What kind of emoji do you want it to show? If we want to go even deeper, which I'm hoping you're going to continue after this, you can make it do other things within that space that you once you see a thumbs up or you want to see it thumbs down. Some of the ideas we could use is, okay, the machine is doing something, and when it sees a thumbs up, it keeps going. It sees a thumbs down, it stops. You can add all that within the spaces, whatever you want to happen in there. So this is just like a taste of a gesture machine. So now we just added that else if option. So I'm gonna go ahead and run it so we see what happens. So let's see. I'm gonna bring the camera up. So it's giving the side eye because it thinks I'm like a thumbs down, which I don't appreciate. But I'm gonna move over to the side and give it the thumbs up, and then you see a smiley face and give it a thumbs down. Let's see my camera. It's thumbs down, and then gives the side eye. As you can see, I had to adjust myself a little bit because the image sees what it needs to see based on what I captured. So there's a lot of things going on in my background. So it's like, oh, something similar, right? Let me see if I can hide myself. It would recognize it as something else. Like, I don't know, what is this? Well, I don't see it changing. It's still thinking it's a thumbs down because it sees some of the other images in the background. But that's the beauty of what you're trying to achieve here. You want to have enough image so that your machine behaves in a particular manner. So right now, if I feel like, okay, the machine is recognizing me as a thumbs down, which I don't appreciate machine, I could go back there and gather more images and go back and redo it again and train the model and export. So you don't just rest on your odds and say, oh yeah, it's fine. If it's not fine, you can train it some more. So the more you learn, the more data you give to your machine, the more your machine is going to work better. Same goes for you. Like the more you learn something, the better you are going to be making a decision around that thing. So I hope you've been able to follow me step by step. So you can slow down this video and walk through the steps. And if you have any issues, you can Google it. You know, you can ask questions with your peers. You can ask a mentor. Everything is possible. There is no limitation to what you can do with your program. You can expand on this. You can add a third classification, add an additional else if like, okay, if you see something else like this, do that. That might make your machine to be able to even be better training. I can add my face and say, when you see me just looking like this, call it something else. And that will make it to be able to say, okay, maybe it's not a thumbs down, it's a face. That means something else, then it starts identifying different things. That's how the machine works. So the more data you give to your machine, the better it works. Now let's go back to our slides. I've walked through all of this and we have been able to see, added our predictions, added to line 72. So right now we're just going to go ahead and wrap up. Does anyone have any questions? All right. So I was,
I'll just
You have a question?
Back to how much I enjoyed this.
Okay, so at this point in time, I want you guys to show your working app. This is an app. Go up, show it to somebody else. If you want to be funny, you can add a comment when they do thumbs up or thumbs down. Whatever you want to do, the word is your oyster. You can train it with whatever data you want. I did train mine with my teddy bears. I had the pink one and I had the brown one, and I just did all kinds of things. So there's so much you can do here with your um, new skill. Now you're a data scientist with machine learning skills.
And can I just add a comment to what I saw as I'm also on this learning journey? Is there's different tools for machine learning. So TensorFlow is the one that we used for this one. So just to sort of start learning the vocabulary. There's different ones like IBM Watson and scikit-learn and other different tools that we use. But today's we were using TensorFlow.
Yes. Thank you so much for that. And what we're going to do is we're going to create a package of tools so you can have a knowledge base so you can learn some more. This is more giving you a hands-on experience to get you excited about machine learning. And that way, when you're learning the new journey, you don't get discouraged. So, how would you use a teachable machine in your home or school to automate an activity? I want you to be thinking about that because all technological inventions come from the fact of technological push and society pull. So when you walk around and you're looking at what's going on in the society that needs to get solved, what's going on in my house that needs to get solved, and you hear about, oh, this machine learning that I can use to do this stuff, guess what? You start coming together and put those ideas together, and that's how innovation comes. It's not a magical star that falls from the skies. This is the secret. Don't tell anybody. Oh, of course not. You can tell everybody, but actually, you look around, and whenever you walk in, this is your creativity walking around. You're like, oh, wouldn't it be nice if I can do this? You say, let me just Google if there's any technology out there that can do this, and then you bring those two together, and then you create something new and innovative. So I want you all to start thinking about how you're going to use this. So machine learning, let's talk about a few of our key takeaways here. Machine learning is the process of letting computers determine a new set of rules called models. And learning computer science is hard. We agree. So we ever encourage everyone to Google everything and to use your resources. Every one of this new technology you see out there, this is how we got it done. I'm letting you on the secret. You too can do this. So, do you have any questions for me about machine learning or how do you continue learning machine learning? All right.
Well, I welcome the question of how to continue learning because I'm just at the beginning of my machine learning journey. I have a few things that I found that I would share with others as well, but I welcome it from you to you for you to lead that first.
Yes. And so, if you join our Slack channel or Discord channel, you're going to have access to Philippa and Elizabeth, and they'll be there to answer your questions, share more tools, share more information, take you even deeper dive into machine learning because this is just the surface. We haven't touched, we're just touching classification. There's so much stuff there. And I'm really excited to see what you all can do with this. So, like I said, if you go to our website, you can see our a link for joining our Discord channel, our Slack channel, and definitely there is our machine learning uh, channels where Elizabeth and Philippa will be leading and putting in details and tools and documents for you to learn more. We actually have a folder in there right now with a lot of information for you. So thank you for joining us. This has been absolutely exciting. I hope you all will be practicing.
Thank you. And when you're learning, also bring a friend. Don't come alone. Bring a friend.
That's a fact. That's a fact. Always share your knowledge. And that's a really good way for you to even keep growing your knowledge when you share knowledge. Knowledge is one of those things that doubles when you share it. I like that.
Absolutely. And I was going to say, so some of the other tools that I've found along the way is that, we all know each other through our community through Google as Women Tech Maker ambassadors. And that has, so part of it is bring a friend, and also you'll make new friends in these communities. And I'm also a Microsoft student ambassador, student learn ambassador. And so I'm just starting on the Google Cloud Skills journey and on the Microsoft Cloud Skills journey. And so both of them have these really cool learning paths that are free, and that people even like myself get rewarded for training you and teaching you and getting you skilled up in these things. So there's a lot of resources and leaders who will happily walk you through these different learning paths related to AI, machine learning, and cloud skills.
Use your
Yeah,
resources.
that's lovely. Yeah, that's lovely. I'm a member of the British Computer Society, and I'm also a mentor, and I have a lot of students that I mentor. So when a lot of people see the British Computer Society, they feel it's only for people who live in Britain. No, anybody could join the British Computer Society. Um, there is a plethora of resources to be harnessed from that. You get to have a personal mentor if you want, and you get to access different things from it. So you could look that up. British Computer Society is very vast. I think it's one of the society that I see is very, very into people and wanting to make people learn. So there's a lot of resources to get from that. So just wanted to add that.
Thank you guys. See, I mean, the opportunities are endless. You're gonna have these two TAs on our Slack channels, helping you out, giving you resources, connecting you to other resources like the Microsoft Cloud that Philippa just talked about, the British Computer Association, Elizabeth just talked about. I mean, amazing, amazing opportunity here. So connect to Steam Divas, stay connected to these ladies. I don't think machine learning is all they can teach you. And really, we want to take everything to the next level. This is what we do with our creativity. We need to come up with something else. And
I,
machine learning
I'm gonna
will
I'm
give
gonna
it
I'm gonna
us.
volunteer the GIS. So when everybody here wants to start learning about maps and data maps, I study geospatial. That's my jam. So I am very happy to talk, because I think a lot of people think about maps and they're like, well, wait, okay, there's Google Maps. So when else do I use a map? Like, I had the idea, weren't all maps created like in the 1800s and they're done? It's like, no, we use maps every day, but there's also art maps and data maps, and you can tell all sorts of stories with maps. And maps are incredibly powerful, as not only just in utility, but also in telling stories and understanding that we live on a globe, and yet we tell stories with a flat map, meaning that there's always distortion, and we choose the distortion we're willing to have sort of support our narrative. So there's a lot but they're really beautiful, and they really talk about STEAM. You can really, to me, they're the perfect intersection of art and science.
Awesome. Awesome.
And
Really
Yeah,
and
I
cool.
and
completely agree.
and to Elizabeth, I have a lot to learn from you, because my goal is actually to be a GIS developer. So I want to learn how to,
Oh,
really sort of create these maps, but really also be able to do the coding and the software development part of it as well.
we have a gem called the geocoder. So geocoder is
Hold on, I missed what you
basic
said. I heard
API for map.
geocoder.
Yeah, so geocoder is a gem. So it's a gem you put into your code so that you can be able to use maps. So the first time I used geocoder and I had to go into in-depth research, it's so vast. Everything about maps is so vast. And I had to use a map API for transport for London, we call TFL. I could see the kind of work it takes to actually come up with that. And it's a very good thing you're doing. I couldn't wrap my head around it. It was so much. I just picked what I needed to pick, and I had to leave I had to leave the rest. But it's quite extensive, very, very extensive. Very, very.
That's awesome. I mean, we're making connections here. So, hey, like, let's keep this party going. I'm really excited about next level. Uh, we're
Well,
gonna
I
try
see
to.
Elizabeth. I see Elizabeth talking, but I'm not hearing what she's saying.
Oh, you're not hearing Elizabeth?
No, I see her talking, and I want to hear what she's saying.
Oh, I think she's there's a delay with what she when she talks. But
Can you hear me now?
yeah, I
Yes,
hear you.
now I can. Yes.
Yeah, I said we have a gen called a geocoder. So geocoder gives you an access to maps. So when you install the gem geocoder into your code, you can be able to put in maps into your code. So when I did that, I was supposed to attach an API of TFL, that's Transport for London, for a project, having to go through the research of having to learn about it. It's so extensive that I couldn't learn all. And I appreciate the people who took out their time to work on maps and geological codes and every other thing. It's awesome what you guys do.
Oh, thank you. Yeah, there's anyways, I welcome bringing it here as well. And like I said, I have a lot to learn about development. And so, yeah, I think the real secret to all of this for everyone here is find joy in learning.
Yeah, I completely agree. And I think
True.
that I'm sorry, Elizabeth. You think there's a delay? What were you saying?
No, I agree with you.
Yes, I absolutely love the fact that we are a group of women where we connected was in tech. We have a passion for learning. We have a passion for getting the next generations going. And so we want you guys to see a spectrum of every one of us doing something different, but still connected. And so I want you all to still maintain your uniqueness, your authenticity, your individualism while you're connecting with STEM. You don't have to be anything but yourself in this environment. So bring in your creativity, bring in your artsy, and bring them into STEM. And like some of you, you notice your models were completely different from the way we thought about it, but it still works. So that's just great. And I just want us to encourage that mindset going forward. But we are at the hour, and it's been lovely hanging out with y'all, and I really, really appreciate it. Such a great moment. Thank you so much for coming.